Good evening. Can you hear me, Avni? Hmm. Yeah, Avni, can you hear me? Hello.
Yeah, I can hear you.
Okay, okay. Just 1 minute. I'm just checking with others. In a minute. Good evening, Mahesh.
Hi,
And hey, Mahesh. Okay, let us start. So we discussed about Snowflake roles, and I hope you got a understanding of what is a role and how we can create the roles and how to grant the privileges to the users with the roles. And this role-based access control generally will be managed by the like administrators, but however sometimes as a senior developers we may need to also jump in and grant the privileges and all, so that understanding we should have. And coming to the next topic which I want to discuss today is the virtual warehouses and how they are going to impact the query execution speed and how they are going to control majorly the compute cost and how we can go and reduce the query response time by leveraging or increasing the warehouse size, and all we will see that today. And let me share my screen. I hope you are able to see my screen.
yes,
So what is a virtual warehouse? So when I say virtual warehouse, most of the people will be an assumption that this is a data warehouse, which is not correct. A virtual warehouse in Snowflake represents a group of clusters and where your compute will be dependent on these particular clusters. So each cluster again a group of machines. So every virtual warehouse in Snowflake will go and will be created as a single cluster or multi-cluster warehouse, and this virtual warehouse will is responsible for running the SQL statements in your Snowflake environment. And this virtual warehouse generally will come up with different sizes, like our t-shirt size and X small, small, medium, large, X large. So like that we have multiple different sizes up to 4x large and 6x large also. And the size here will determine how fast your query will execute. At the same time, each size will have a different number of credits will be consumed per hour. A X small size will consume 1 credit per hour. A small size will consume 2 credits per hour. So when the size increases, your consumption will increase and your cost will increase. So as a developer, how you are going to leverage and how you are going to reduce the consumption is very important. And when to resize. So you can instantly resize also, which is called scale up and scale down. I can increase the size and I can decrease the size also. Even my queries are running. The Snowflake will never restrict you to increase this size like x small to small or medium to large or 3x large to 4x large. I can increase. But even my queries are executing, Snowflake will allow you to increase or even decrease also. And this particular virtual warehouse also will have two important properties called auto suspend and auto resume. So this auto suspend and auto resume are basically configured for the cost efficiency, and Snowflake will charge you for virtual warehouse cost per second billing. And auto suspend means as whenever my warehouse is idle, which means that no queries are getting executed, I want to Snowflake to automatically suspend the warehouse to like reduce my credit consumption. And auto resume is the feature which will enable to see whether my warehouse need to be automatically started whenever I will start executing my query. So whenever I start like select start from table, so I want then only I want my warehouse should be started. If my warehouse like my no queries are running, I do not need my warehouse to be started at all. It should be in suspend mode only. So all these can be configured. While creating the warehouse, we have a set of properties to configure. And one particular thing what Snowflake generally will do is whenever you start creating any warehouse, the nature of Snowflake is to automatically start the warehouse, which is not correct. So there are the properties like the initially suspended equal to true. This property need to be set up for every new warehouse which you created to suspend the warehouse whenever it started. If you don't, if you don't do that, so your warehouse will be automatically started after you create it. But the initially suspended will true equal to true will stop the warehouse once you create it, because we can enable auto resume anytime when you want to run any SQL query. The auto resume will anyway start it. So when no queries are running, no credits will be consumed, no cost will be calculated. So we should have the clarity. Clarity in the sense when to increase the warehouse size and when to increase the number of clusters also. When to increase the number of clusters. If there is a parallel execution is happening, multiple users are running multiple queries and they are experiencing some challenges and some like delay in query performance. That is basically the challenge is with the warehouse that does not have enough number of clusters. So our requirement is you need to increase the number of clusters so that your parallel and concurrent execution will be improved. That is called scale out. And assume that you are running a complex query which is required a dashboard to be generated for a critical user. And this query is
Sorry
taking.
to interrupt you, Sriram. Sri, I have a question actually.
Hmm.
To increase the clusters means,
Hmm.
I mean, the size or
No,
the
size
quantity?
is no quantity, number of clusters, minimum and maximum. There is a property.
Okay.
So number of
So if we
clusters.
increase the size
Hmm.
from excess to
Hmm. X small to
medium or
medium.
large also, I
You
mean,
can
whatever the runtime it is taking.
correct.
So, I mean, if we increase
Hmm.
also, the performance will increase. No, why to increase the clusters then?
I will tell you. See,
When we are running on the multiple
users.
queries or the transaction,
Hmm.
that situation it will help if I am not wrong.
Correct, correct. You are right, Mahesh. That's what I'm telling. So when multiple queries are running, right, increasing the size is not going to help you. We need multiple machines here. So multiple machines and multiple resources need to be provided to multiple users for the parallel concurrent execution. In that scenario, I need to increase number of clusters. if a single query is taking a long time, then because it requires additional resources to store the memory, CPU, because every warehouse based on a size, it will be having the number of nodes. It will be decided. A small may have 2 nodes. A small may have like 4 nodes. Medium will have like 8 nodes. 8 nodes means 8 machines. If the number of machines are less, right, the query, if it is long run, is managing huge amount of data, my existing machine's RAM may not be sufficient. Correct, no? Then what I need? I need additional RAM and additional CPU also, right? Correct? Are you getting? Yamini?
Yes, yes.
So
Got
when
it.
you are
Yeah.
increasing the size means you are increasing the capacity, like number of like RAM capacity and number of CPU, virtual core. You are increasing that so that my query which is running long may be going to leverage this and run faster. If not, what will happen, right? Your queries will go and sit in the local disk or remote disk. So what will happen if my data is in the disk? The extraction will be slower, right, from the disk. If you go and see my queries are running directly from RAM, my results, it will be faster. If my queries are getting the results from a disk means they will definitely will be slow. So this is one of the common issue in most of the Snowflake environment or projects where your query will be, the results will be extracted from the remote disk. Sometimes where your queries, the results are not fitting with the RAM. That is called data spilling. So you will see in a query executed how much amount of data is spilled to the disk also, remote disk. If you see more amount of data means you need to go and increase the size. And when you're increasing the size of the warehouse is called as scaling up the warehouse. But as Mahesh mentioned, multiple queries are running. So what happens sometimes every user may experience the latency because even we are running multiple queries, your environment, my environment is same also, but the clusters, number of clusters may not be sufficient. So my warehouse may be busy. Correct? No, my warehouse is busy means running other queries. Your query will make queue, right? Correct or not?
Yeah.
So when your query is queue means you have to wait. But if you don't want to wait, the warehouse need to be increased with the number of clusters, that is called scale out.
Got it.
So when to scale up and when to scale out, we have to decide. So that is basically when data scaling occurs, increase the size. Small to small, small to medium, like that. If there is any concurrent execution is impacting, increase the number of clusters, it is called scale out. Okay?
Yes.
And every warehouse, right? Every warehouse in our virtual warehouse, you call it as, when it is running, it has to determine how many number of resources required. At the same time, every warehouse will have a scaling policy. The scaling policy will decide, like when I say scaling policy here, it will be two types, standard and economy. And I see this is the example. A virtual warehouse of X small size will be like this. How many nodes are there in this? 4, right? The memory is only
Yeah.
four set of RAM is available, and 8 virtual core CPUs, and 4 local storage, and 4 remote storage. If my data is unable to fit on this, right, I need to move to small or medium, which will increase this RAM capacity. Are you getting what I'm trying to say? Yamini. So
Yes, yes, yes.
this small X small to small increases this memory capacity, CPU capacity, so that your query will have enough resources here. If it is this is not like enough, right? My data will come and sit in this particular remote disk. You can imagine if my data is in remote disk, how slow it will be. Correct, no? My data is remote disk means it has to go and pull from remote disk, it will take time. A disk is always slow compared to RAM. So a virtual warehouse requires to mainly for speed up your code execution and data processing and parallel execution also. but the parallel execution or the like single query execution, both are important here, right? I cannot go and skip anyone. So in both cases, I need to either scale up or scale out. That is what you have to understand. Okay. So generally, the importance of virtual warehouse is also the main objective in Snowflake is to run SQL queries faster. And SQL query can be anything. It can be select query, or it can be insert query, it can be data loading query, or it can be like any kind of query. And can be connected to a report to pull the data, and it can be a ML model also. ML model which is running in the background. So most of these particular activities which involves SQL query requires a warehouse to be up and running. Without a warehouse, you cannot go and run any SQL queries in Snowflake environment. So smaller sizes and larger sizes. So when I was talking about the data spilling concept, right? The factors a virtual warehouse is always will be dependent on is like I need to resize the warehouse whenever my longer execution time, a complex query is taking long time and which is not responding and which is running for long term, then I need to increase from X small to larger. So when is a large, see number of CPUs it got increased, right? Correct or not? Yes or no? The smaller memory is increased to larger memory. And high compute nodes came here for parallel processing at the same time. So the execution time will be faster. The local cache will be increased. When the local cache increase means your execution will run faster. Your query cache capacity will increase, but the cost also will increase here. When you increase the size, ultimately your cost will increase, right? Yes or no? If you want to experience a better performance, you also need to spend some money. So the scale up also will increase the cost. At the same time, we can go and experience the scale out also if needed based on the user's requirement. And what are the factors that is important to decide the virtual warehouse size also? So this question so many people will ask many times. The factors which will impact a warehouse size is the first one is data volume. If my data volume is not huge, I definitely need to go with a small size is sufficient. Because the RAM whatever is available will need to process large amount of data, means it needs enough resources also, or else it will go and go for data spilling to remote storage. When you go to data spilling issue, you need to experience the delay and query complexity, because not every query will involve the complex joins, aggregations, window functions, all this. So these are all cost-based operations. So the query complexity also will be one of the biggest challenge, which requires high computing capacity, because heavy calculations will benefit if you have a like a high compute is available, because larger size of like warehouses will provide more CPUs and faster execution for the complex logic. We need to go and see a larger size is important based on the query complexity. And concurrent execution, multi-user queries are running, so we need to increase the concurrency. Concurrency means the number of clusters need to be increased. So multi-cluster required here, not single cluster, because that will avoid waiting in the queue. And finally, the SLA performance, because the latency, not everybody will be ready, because if you have a SLA to finish the report within 10 minutes, and if it takes more than 10 minutes, you are breaking a SLA and you will experience some challenges from the customer also. So we should be very careful in this particular factors which we need to consider. And coming to like the warehouse size type is also important here. Warehouse size is one area and the warehouse type is another factor. The warehouse type is we have like three different types. Standard is there, Snowpark optimized, and third one like Snowflake generation 2 also is there. This is Snowflake generation 1, the standard one. Second one, Snowpark optimized. The third one, Snowflake generation 2, which is not available here, but there is a newly like added warehouse type in Snowflake. And standard is a balanced and a basic level of like CPUs will be available, and cost also will be very less for the standard. If you go to Snowpark optimized warehouses or any generation 2 warehouses, your cost will be more. Your warehouse size also will go and impact. So we need to choose the correct warehouse size and warehouse type also. It's not like only size, the type is also important because your cost will be impacted by the warehouse type also, because my high memory intent solutions need to be implemented. I need to go and use Snowpark optimized only. Normal warehouse is not going to help me. Only Snowpark optimized warehouses can help us to process huge amount of data. So what are the like warehouse factors that will influence the warehouse? Data volume, query complexity, concurrency, and performance. All these four required to select the warehouse size with the right size. And coming to like the virtual warehouse, we have like different virtual warehouses for different teams also. So every team may not require the bigger size. Maybe Looker team, which is a dashboard team, may require only small or small size. And maybe other users, like for example, I have a finance team, or I have a like a sales team, or a data science team, they need a decent size. So the compute need to be increased, because here if you see the virtual warehouse, according to the size, how many nodes are there, how many missions are there. Here XMall contains only one node, small 2 nodes, medium 4 nodes, large 8 nodes. So it will keep on increasing. So when the size increases, your number of nodes will increase. At the same time, you will experience some like performance improvement also if you increase the number of nodes. So that is very important here. And XMall and 4x large. So XMall is the very basic level size which will come by default, but according to your data volume, you need to see which one is the best one. Because if you have petabytes of data, XMall is not going to help me. Because I need to go and look for a bigger size like 4x large only. Because petabytes of data means you can imagine how much amount of data. So normal XMall size will never going to help us. You need to resize the warehouse to a bigger size. Clear? And sizes also you need to understand.
Srini, I have a query here.
Please go ahead.
Like, if currently, let's assume that I am using XS.
Okay.
So from there, can I directly jump into 3x large or
Can.
6x large, something like that?
Can. There is
Okay.
no restriction that you should not go directly to bigger size. You can go.
Okay.
Snowflake will never restrict you to go from small to bigger, because this user choice, right?
Yes.
Because your query is, you know how complex it is. Snowflake does not know, because since you will have control over that, because you can go and change from small to small to medium, or directly from medium to 6x large also. But the only thing which you need to keep in mind is, do you really require that much bigger size?
Yeah.
What
That's
factors are important? You need to understand the volume, the complexity of the query, all important, because the number of virtual CPUs will increase, means you are doubling the capacity also. If you see here, this XLR 5x large, 6x large are double the capacity, huge, very huge. You can see here number of nodes also like very high compared to the normal sizes.
yeah.
So if you have
And this
petabytes,
scale up and scale down activity can be performed by sysadmin or more, right? Or
sysadmin
per
can do, sysadmin can do because the only thing here, right? The size can be, I can change, but I should have that privilege also, no?
yeah, yeah,
The privilege is important. See, if you are sysadmin, you can create the warehouses, all this stuff. It doesn't mean that you can change it also sometimes.
yeah, yeah. From sysadmin to above system roles can be able to. And
Security admin,
sysadmin should have the privileges.
privileges. Sysadmin can only create, but control, granting and all will be done by the security admin, right?
Security, security and above.
Security admin only can do. The security admin can only grant the privileges. So you need to reach out security admin to provide. For example, I want to increase from X small to 6x large. You can do that, but you need to reach out the security admin person because he will have the control to change it. Because if he give everyone 6x large, you can imagine how many queries they will execute and do they really require that bigger size also important, right? Every team may not require the bigger size, correct or not? That depends upon the team capacity and how many queries are they running. That also
Yeah,
matters there.
based on the load. Yeah.
Exactly. Based on workload only you'll decide. And while creating also, you will try to see like, see directly I'm giving small here. Generally, nobody will give like bigger size here. People go with either X small or small, they will start with, and if they really require, they will increase in future. So initially suspend equal to true. This particular
Mm.
property will try to suspend your warehouse after started. If you don't add this property, what happens? Your warehouse will be automatically started. So when you start this particular, when you create this warehouse, Snowflake will automatically start it if you don't add this property. So
Mm.
initially suspend will be false by default. So unless you are starting, right? Correct or not? When no queries are running, do I need to start this warehouse? No, right?
No.
Generally, assume I am creating a warehouse and no queries are running. But even my warehouse started, even there are no queries are running means you are wasting the credits, no? Correct or not?
Mm.
So which means that when you don't have any queries getting executed, and you should initially you should suspend it, this property. So while creating, we will configure that. And auto suspend 60 seconds means 1 minute. But this is also not correct because for every 1 minute it will automatically suspend, right? It is not like for every 1 minute you will run the queries. Correct, no?
Mm.
Sometimes every 15 minutes or you will have a time gap also. So your auto suspend should be, it will be good if you go with maybe 600 seconds or 300 seconds. So which will be converted into minutes. 600 seconds means like it is how much time it is in minutes? 600 seconds means 12 minutes, right?
10, 10 minutes. No?
10 minutes. Yeah, 10 minutes. So 10 minutes is fine because most of the people will give 15 minutes also in seconds. So according to your query's execution time, you have to decide, right? Correct or not? There is a long gap between query to query. So I do not need my warehouse to be running, no? Correct or not? Maybe 9 to 12 only my queries will, I have a like a high date workload and queries will execute. And after 12 and before 9, I do not need that much bigger warehouse size also. I will resize back to the X mall. Only from 9 to 12 only, I'll increase the size to maybe 2x large. After my queries, my report related queries completed, after 12, I will immediately resize back to the X mall. This will happen. So to make the queries to run faster because there might be some critical queries will be running, which the users will be waiting. I hope you got it, what I'm trying to say.
Yeah.
So this is how you will generally create warehouse name with warehouse size equal to medium, auto suspend 300 seconds, which is 5 minutes, and auto resume true. and minimum cluster, maximum cluster. And here I am creating a multi-cluster for concurrency. Correct, no? So for concurrent execution, we need to enable this particular max cluster to 3. And if at all I want to experience auto scaling, I need minimum 2 clusters. Correct, no? In a warehouse. If I have single warehouse, single cluster, so I cannot go and do any particular auto scaling and all. So auto scaling means what? I need minimum 2 clusters so that if any time I require additional clusters, Snowflake can go and allocate. So number of clusters should be minimum 2 and maximum I can even go and add 300 also through command. And the scaling policy standard and we have economy, 2 different types. So what is scaling policy and what is economy policy is, and scaling policy standard is the default one. So which is basically will indicate, and whenever you run any SQL query, the standard policy indicate whenever there is a requirement of additional resources, the standard policy will ask Snowflake to go and verify consecutively. It will verify within a span of 2 minutes only 1 or 2 times. And if it finds no running cluster available, it will go and find out any idle cluster and it will allocate that. But economy policy is not like standard. If my warehouse is created using economy policy, here instead of standard here I will change to economy here. Then my warehouse will be a economy like with standard policy. So economy standard policy warehouse means it will try to perform 5 to 6 times continuously. It will verify is there any running cluster. It will wait for the running cluster. It will be in the queue, and whenever running cluster available, then it will allot. It will not unnecessarily go and kick off or spin any idle clusters if needed. But this will happen in the warehouse is under standard policy. So which is the better one? Economy is the better one with respect to the cost. Correct, no? It will try to utilize 100% all the clusters. But standard will not. Standard will not even wait for 2 to 3 times. After 2 to 3 times, it finds there is no any running cluster available. It will see any idle cluster available. It will immediately go and allot. I hope that is clear. The difference between the standard and economy policies. Are you getting? Everyone?
Yes, yes.
And if you see here, there are 4 different teams, right? 4 different people, and they are using 4 different types of warehouses. For example, Looker team is a dashboard team, right? And they will review the data. They will only review the data. So we are giving them a single cluster warehouse only. If you see 3 nodes, whatever it is. But this particular Power BI team, they do some marketing analysis. So we are giving them a 2 cluster warehouse. And DBT team, they do some kind of ELT processing and all. We are providing them a 4 cluster warehouse. And this particular data scientist team, they do so many complex calculations in deep learning and artificial intelligence and all. So they need a decent size. So we are giving them 8 cluster warehouse. What you have to observe here, every team may not require same size, right? According to the team capacity, we have to decide, correct or not? Are you getting what I'm trying to say now?
Yes, yes.
The data volume will be high here also. And the query complexity may be different here and here. And here it may not be same, right? See, Looker team is just a dashboard team. They will simply go and review the data. They will not do anything else. Power BI team is they will generate some dashboards. So we are giving them a 2 cluster warehouse, which is better than what Looker is using. So according to our consumption and utilization only, we need to go and decide what is the type of warehouse we have to allocate to the user. And how you allocate also, we will go and create that warehouse separately and will grant the access to roles. Grant usage on warehouse to role name. And this role will be assigned to the user who wants to access that warehouse. I hope that is clear. And scaling up and scale out is nothing but here number of too many users are there. Correct? No? Can you see that? Too many users are coming in waiting in a queue. So what you have to do? We need to increase the number of clusters here for the faster service and faster response. But any query is like a running very slow. My small size is not sufficient, so we are increasing the size to 4x large. Any heavy queries or bigger queries, we can go and I need the warehouse size need to be increased here. Scale up, we call it as. Scale up means increase the size. X small to small, small to medium. Because X small may not be sufficient. So we need a high capacity, so we are increasing the size here. But here, multiple people, see how many people are in a queue. Because their queries may be running slow. They might be in the waiting queue. So to make them like run faster, we need to provide multiple different like clusters required. So we will try to go with a multi-cluster warehouse here. I hope now it is clear, everyone. This is scale up and this is scale out. Clear? Jamani, now I hope you are able to understand, right?
Yes, it is clear for me.
Okay, cool. So apart from this, right, we need to understand like when the queries are getting executed, every time the query is executed, a query plan will be generated. That query plan will be generated and that will be like utilized to run the query. And during the query plan generation and executing the query, Snowflake will consume the credits. When the credits are consumed means for the first time only they will consume. The same query is running again. Your results will be sitting in the query cache up to 24 hours. So second time onwards, there will be no credits consumed. And Snowflake will go to query cache and it will get the results. The same query is executed by either me or you. Both will get the results from the query cache only. If the query is involved in petabytes of data also, Snowflake is not going to charge us. Snowflake is going to get from the query cache only. Even my data is in petabytes, it will pick up from the query cache and display us. In that way, it is helping us, the customers to reduce their compute cost also. So caching is one of the important concept which will help us to reduce the compute cost by getting the result from the query cache, which is by default available in Snowflake environment. I hope everybody is following now. And this is what I was talking about. Auto suspend, auto resume. So 5 minutes of inactivity and it is going to like wait for, it will automatically suspend. Snowflake will automatically suspend the warehouse because no queries are running. But here, whenever a query is like my warehouse is in a suspended mode, whenever you start any query and the Snowflake engine will automatically start the warehouse because it requires the resources. So your credits consumption will be started whenever your query execution start. And scaling policy standard and then economy. Standard will minimize the cost, whereas economy will maximize the concurrency. So most of the people who are willing to run the parallel execution, which means will increase the number of clusters. That too parallelly, not like sequentially. The clusters will be added in parallelly to maximize the concurrency if it is a economy. But in case of standard, it will be go sequential order one by one. Because according to the demand, it will go and try to add it. It will not immediately go and add. So concurrency and performance both are important here with the standard and economy scaling policy. So auto suspend, it will automatically stop the warehouse after 5 minutes of inactivity, and auto resume query will query detected, so immediately start it. So this will be done, both will be done automatically, but we need to enable them. Auto resume should be enabled equal to true, and auto suspend need to be configured 5 minutes or 10 minutes or 15 minutes according to the time. It will try to suspend the warehouse if it is not getting utilized. And let us try to see some examples. So I'm trying to create some set of warehouses here. So I'm creating a small size warehouse with the name demo warehouse, and auto suspend 300 seconds, which is basically like 5 minutes, and then auto resume equal to true, because I'm enabling my warehouse to be automatically started, and the minimum clusters 1, maximum clusters 5, scaling policy standard, and this comment indicates what is warehouse about, and I'm also adding the initially suspended true also. So this is going to create a warehouse with the name demo warehouse, and with X small size, with auto suspend 5 minutes, and the minimum cluster 1, maximum cluster 5 of the standard policy, and initially suspend also will be true. So let me try to run this. See, this has been created, but how to see that? We have a command called show warehouses, and this is going to show us what are the different warehouses available, and we just create a demo warehouse. You see, whatever the warehouse we created, that is a demo warehouse. And this demo warehouse, we can see here, it is a in suspended mode with the standard type and X small size, and a maximum cluster 5, which is a multi-cluster warehouse, and auto suspend 300 seconds. And we can use this particular warehouse, and then we can start running some queries and see one by one. So let me try to use that warehouse. So I'm pointing to the same warehouse here. So demo warehouse you can see here. Now we will try to use the Snowflake sample data and SF10 TCL schema. And what we have to do, see, when you want to see the impact of Snowflake, we need to disable the query cache also. If you don't use query cache, you will see the difference. But before that, I want to run like a complex query which involves some joins and functions and set operators, all this stuff. And we are going to run this and see how much we're going to take generally. So it may take some time. So it took 12 seconds. Can you see that? Everyone? Sorry, 1.3 seconds. Huh? How much time it took? Yeah, 12 seconds only. So it took 12 seconds to complete. If I run the same query again, this time it will not take that much. It will finish 93 milliseconds. Can you see that? Everyone? For the first time only it took time because it has to generate query plan, and according to that the query has to be executed. But in this particular case, your execution time is reduced because query cache is generally will store the results, and whatever the results you are getting from the query cache only. And what if I want to reduce the time? I cannot go and see the time reduction if I use the query cache, because query cache is not going to touch the warehouse at all. So I want to see the difference, so I'll disable the query cache for now. And now I'll execute the query once again. So, but before that, we will try to see the warehouse. Is xml here. Okay. So let me try to run this query once again. Just taking 12 seconds. And I'll run the query once again. Let us see how much it will take. It took 7.8 seconds now. So okay. So because my query cache is now not enabled, it is disabled. So I'm using, and the query is taking the help of the virtual warehouse and running. So we're saying 6 seconds every time it is reducing, but however, still it is showing as like 6 seconds. So like I want to reduce this particular time. So to achieve that, we need to increase the size. So I'm changing the size from small to small here. Now, if I go back and see, my warehouse size might have got changed to small. And I'll try to increase the size. So alter, we changed the size. Now I will see the show warehouses, which is small now. And I'll run the same query once again, but under small size. And let us see how much time it's going to take. It took 4.9 seconds, which means it reduced, right? Yes or no? This on 7.8 to 4.9 means it reduced, right? Correct?
Yes, yes.
So the size increases, the response time will like decrease. Let me try to increase from small to medium now. I'll execute the same query once again. Let us see how much time it's going to take. 11 took, see, now it reduced to 3.3. Correct or not? 4.9 to 3.3 it came down. So what is the conclusion here? When the size increases, my query response time will decrease. Are you getting, everyone? And my warehouse also I'm just suspending, and then I'll try to like disable the auto suspend also, or auto resume also, to see, because we don't use these particular features, you cannot see the difference. So I will go and try to like suspend resume, resume the auto, sorry, change auto resume to false. Compute warehouses, demo warehouse, auto resume I'm disabling because I manually want to execute this. So as of now, my warehouse demo size is still like medium only. I just need to run this. So let me try to go back. Okay, it is saying warehouse suspended. We need a warehouse to be up and running. So without a warehouse, see, it is not allowing the warehouse to be up and running. So let me try to say use warehouse. What is the warehouse name? So here medium size. I'm just trying to run this. So I resumed it. It took 30.4 seconds. So when you increase the size, it is reducing the number of like seconds to complete. If I go with the query cache enabled, right, it will take even further faster. When I run this, now it may go and say 178 milliseconds. See how fast it is. So the query cache is going to help us. The query cache is basically a inbuilt feature which Snowflake is offering, which they will maintain, and my query results will be stored in query cache every time. But I want to separately discuss about query cache, but I don't want to include that here. But you understood the importance of virtual warehouses while running the queries, right? All of you. What is the conclusion here? When the warehouse size increases, my query execution speed will increase, right?
Yes, yes.
The size of the warehouse will determine how fast the queries will execute. That is important. If it's a single query, you can see the difference. If the parallel queries are running, then increase the number of clusters.
Clusters. Yeah. And
That
Srini,
is what I want to conclude.
Srini,
Hmm.
able to hear me?
I'm
Hello.
sorry. Tell me. I can
Able to
hear.
hear me? Yeah, yeah. Srini, I have a question.
Hmm.
When you created the cluster
Mm-hmm.
I'm sorry,
Warehouse.
demo warehouse,
Hmm.
so you have given the count of one and max count of five.
Correct.
So when we wanted to increase
The
the
size.
size, I mean, when we are trying
Number of
to
clusters
run
or
the
size.
multiple queries, so maximum
Hmm.
cluster we can go till five only.
No. We can increase. So no. Not, what Snowflake can use to increase. See, whatever you gave here, Snowflake can only use up to those many clusters, right? To scale up.
Yeah, yeah, five clusters only.
Huh.
So when we wanted to
Increase.
like currently we are running only one cluster, right?
Correct. See, not one cluster. We are giving up to maximum five. You can go. If you go and see in
Yeah.
the compute warehouse, right? It will show five clusters
Mm.
here.
Yeah,
Generally,
five
it's
clusters, yes.
five clusters. It has to show.
Mm.
It's not showing. Generally, it was showing earlier, but here this particular demo warehouse. See, five by. You can see here. It's showing clearly. How many here? Zero out of
Yeah,
five.
0 by 5. Yeah.
So five clusters will be there. If whenever
Mm.
needed, Snowflake will try to use this five clusters from this five. But initially, it may start with one cluster based on our requirement. But if
Yeah.
additionally any clusters are
So,
required, Snowflake will
mm.
use this out of these five and it will try to use that.
Yeah, so max it uses as per
Five,
our configuration, it uses max 5 only, right?
five only
That's right.
for this warehouse. But
Yeah,
for
for this
last one,
warehouse.
for the last one, you see 10 is
Yeah,
there.
yeah, it has the 10. Yeah.
So we can increase this. So I can increase from 5 to 10 or 300
Yeah,
also.
we can modify the configuration. Yeah.
Yeah, we can configuration can we go up to this one
Yeah.
I can go and give up to 300 also.
Yeah, visual.
But we have to see really we require this much bigger one. Correct now.
Yeah.
That depends upon your query complexity. I told you, right?
Yes.
How many queries are you running, your number of queries, and everything you have to calculate and you have to create according to your consumption.
So I have one more question in
Hmm.
front of cost.
Hmm.
Okay, so we have created max clusters 5, right?
Correct.
So, but we are using currently only one. Okay,
Correct.
rest of the clusters are in idle state.
Correct.
When it is comes to the multi-query execution, those will come up and execute the queries.
Correct.
But
Correct.
if we max clusters, if I change it to 10,
Uh-huh.
what is the cost difference? But I am using only one cluster.
See, that's
But
what I've
max
told you.
application,
Whatever
I
you are
created
using,
in
you need to
10.
pay for that only.
Okay.
It is not like you are not using, it is ideal you have to pay. If you are using for only one cluster, you have to pay for one cluster only.
When we are reserving these clusters, like max 10, right?
That's
Will
what I'm
they
telling.
initially charge
Snowflake,
anything?
if required, Snowflake will provide you resources.
Okay.
According to the provision, it will try to calculate and it will add in the cloud services cost.
Hmm.
It is not part of compute cost also. See, nobody can guess, right, how much I'm
Yeah.
going to consume. So Snowflake also will calculate according to your consumption. If required, it will provide the resources what is needed, and according to the resources what it provided, they will calculate and they will add to your monthly billing as a cloud services cost.
Hmm.
Automatically, you will get everything, but you need to pay in the monthly billing.
Yeah.
But that is not visible here in the
Yes.
here in
We
the
have
interface.
discussed that. Yes.
Correct. Are you getting?
Yeah.
Okay. Any other questions?
No. Please proceed.
Okay. That's all. So I want to discuss about this today, and tomorrow I will try to show you the caching also. Why caching is important? What are the different caches available? Like we have metadata cache, we have like local disk and remote disk cache, and we also have like query cache. How they are going to like also impact, and when automatically metadata cache will be utilized, when query cache will be utilized, where to go and verify. I'll show about all those tomorrow. Okay.
Okay.
This script I'll share you. I want you to also try this one and see and increase the size and see how the queries are getting executed faster and how it is going to impact also. Is it clear, Yamani and Kiran?
Yes, sir.
So
Yes, it is.
so please try to work on this. And there is some two assignments on scale up and scale down also, scale up and scale out also, on creating the warehouses. Please try to work on assignments as well, all of you.
Sure, sir.
Okay then. Thank you so much.
Thank you.
Thank you.